Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the course Vector Calculus and Complex Analysis. This course is designed for second BTech students, and today I would like to introduce this course and the overview of today's presentation. Today's presentation covers the following: the topics to be covered in this that we are going to discuss in this course, and then introduction to vectors, and also I discuss some of applications of vectors, where we use vectors. So these are the topics that I am going to discuss today. Now coming to the actual syllabus of this course, Vector Calculus and Complex Analysis. Here this course is divided into two parts. One is vector calculus and then complex analysis. So in vector calculus, we deal with only vector integration and the vector integral theorems. So unit 1 is having the concepts of vector integration. In vector integration, we have three different integrals: line integral, surface integral and volume integral. And this line integral is the generalization of single integral, and surface integral. So surface integral is the normal generalization of a double integral, and volume integral is the generalization of a triple integral to the vector field. So here we define line, surface and volume integrals, and how to evaluate the line, surface and volume integrals that we are going to discuss, and also some applications and vector integral theorems. So here there are three theorems: Gauss divergence theorem, Green's theorem and Stokes theorem. And what is the advantage of these theorems? Using these vector integral theorems, we can convert the line integral into a surface integral. A surface integral can be transformed to a volume integral, and so on. So here the problems will be like to evaluate the line integral using Stokes theorem. Means by transforming the line integral into surface integral, we need to evaluate that line integral. Similarly, evaluate the surface integral by transforming into volume integral using Gauss divergence theorem. Or else sometimes we verify these theorems for the given vectors. So verify Gauss divergence theorem. So verification means we need to find both LHS and RHS, and finally we prove that LHS is equal to RHS. That means both the integrals are the same. So these are the problems in unit 1. Coming to the second unit, here we introduce the functions of complex variables. So what is a complex variable? We know that a complex number is in the form a plus ib, where a is the real part, a is called the real part, and b is called the complex imaginary part, where b is called the imaginary part. So example 2 plus 3i. So which is a constant here, but here we deal with complex variables, that means in the form of x plus iy. So we denote it by z. So z is a complex variable. A function have with the complex variable z. So f of z, we deal with functions of complex variables. So here the introduction part, limit and continuity of a complex function. Then these are the important topics: analytic function and harmonic function. What is an analytic function? What is a harmonic function? That we define in unit 2. And there is a method called Milne-Thomson method to find the conjugate harmonic function. Now in unit 3, we discuss the complex power series and complex integration. So we integrate a function of complex variables. So again here the line integral, how to evaluate the line integral, and how to evaluate the integrals of complex functions using Cauchy's integral theorem and Cauchy's integral formula. And with respect to the conditions, we apply the theorem or formula to evaluate the given line integral. And then power series. So we express the given function in terms of Taylor series, Maclaurin's and Lorentz series. And also we discuss about singular points, isolated singular points, essential singular points and poles. Next, coming to the unit 4, the calculus of residues. So here first we calculate the poles of the given function, then residues, and to find the residue we use the residue theorem, and also evaluation of improper integrals will be discussed in unit 4. And unit 5 is conformal mapping. So here we use the transformations, transformation by some particular functions, translation, rotation, inversion, and also so here linear transformation and bilinear transformation. In conformal mapping we are going to discuss these concepts. So this is about the topics that we are going to discuss in this course. Now coming to the introduction of vectors. There are two types of mathematical quantities that are used to explain the nature of things in terms of direction and magnitude. Direction and magnitude. Those are vector and scalar. So there are two types of mathematical quantities to explain the nature of things in terms of direction and magnitude. Simply, a quantity or phenomena is said to be a vector if it possesses both magnitude and direction. So two independent qualities, namely magnitude and direction. So a vector is a quantity which has both magnitude as well as direction, whereas a scalar is having only magnitude. So when the direction comes, vector comes into the picture. And the concepts of velocity, momentum, force, electromagnetic fields, weight, all these are examples of vectors that can be found in nature. So for example, if a particle is moving from a point A to another point B, to move this particle we need to apply some force, then some work has been done, and in the direction of A to B, this is the direction. So all these concepts are related to vectors. Similarly, momentum, electromagnetic fields, all are examples of vectors that we found in nature. And also the words can be used to express the motion of objects in some situations. For example, a person who has never taken a physics class probably has sometimes they use in their vocabulary can use to describe things that are moving. Simply, for example, that vocabulary includes the words or phrases such as move fast, stop, slowing down, speeding up, turning, etc. All these comes under to explain the motion of objects. And coming to the applications of vectors, so the practical applications of vectors in everyday life, one of those examples is military usage. So in military, the caliber, range, mobility or rate of fire and angle of fire of cannons all differ from one another. So depending on the role that each type of cannon is supposed to play, here the cannon mix and balance these characteristics to different degrees, and vectors plays an important role in this case. So vectors decide whether the projectile will head and hit on the ground. So in military, the vectors are very useful in these particular cases. And also projectile. So vectors are utilized automatically by players in sports like basketball and baseball. So here the student either shot the target or threw the ball, of which accomplished by using their understanding of vectors. So they can play under the knowledge of vectors. In fact, in games like javelin throw, it is necessary to judge the angle that the projectile makes with the ground. So here, in which angle it reaches here. So for example, if to reach this particular position, what is the angle and how much force we need to apply. And also vectors in gaming. So vectors are utilized in storage of locations, directions, velocities in video games, and the position vector tells us how far the object is. So where is the object? And also the velocity vector tells us how long it will take or how much force we need to apply to reach there. And the direction vector tells us how we should apply that force. So the vectors are very much useful in gaming. Not only that, in roller coaster also we use vectors for the construction of the safety system. So vectors of forces, acceleration, velocity will be considered so that the train would be able to continue operating so long time. And this employs the use of vectors in designing the roller coaster ride. And also while playing cricket, if a batsman in cricket hits a shot, there are three possible outcomes: either the catch out, or drop before the fielder, or the maximum score. So again here also, when the batsman hits the ball, it will go projectile nature. So sometimes it may be catch out or catch drop, or else it may reach the maximum distance, that means a boundary. So when the batsman hits the ball, the angle at which he shoots and the amount of velocity with which he hits the ball are both important here. Here the angle at which he shoots and the amount of velocity with which he hits the ball, both are important in determining whether the ball reaches the boundary or not. Similarly, if both of these vectors meet the requirements, if both of these vectors meet the requirement for maximum force, obviously the player will get a boundary. So because of the ball, everything revolves around the vectors in playing cricket. And boat crossing a river. So when a boat travels over a river, there are two things: the speed of the boat and the speed of the river. Both contribute to the total speed of the boat. So when the current speed of the river changes, automatically the course that the boat takes. Therefore the boatman must determine an angle for crossing the river in order to access the shore of the river in a direct manner. Again, it depends on vectors. So vectors plays an important role in boat crossing a river. So all these are some live examples of vectors. And finally, the crosswind. So it's a well-known topic to everyone. A wind that blows in a direction that is perpendicular to the path that one is traveling is referred to as crosswind. The wind that blows in a direction perpendicular to the path of traveling, that is called crosswind. When a plane finally touches down, it will at times experience challenges due to the crosswind. In that case, in that situation, they feel the experience of crosswind. So with the use of vectors, a pilot is able to determine the resultant velocity as well as the direction. So with the help of vectors, he can easily reach the ground. And coming to summary of today's session, I have discussed about the different topics that we are going to discuss in VCCA course: vector calculus and complex analysis. So the syllabus, unit-wise syllabus has been discussed, and also the introduction to vectors and mainly the applications of vectors. So what is the advantage of vectors and in various fields we use vectors, and all these topics are discussed in today's session. And in the next session I will discuss about the vector integration, in particular the line integral. So, in vector integration we have three different integrals: line integral, surface and volume. So, in the next session we discuss about the line integral and we solve some problems on line integral also. This is for today's session and we will meet in the next session. Thank you.